to look at today. So now let us start with the first question here under logarithms. Now use tables to evaluate square cube root of 0.048 times 63.47 all over 13.2 raised to the power of 2. Now to solve this, you have to make use of tables. All right, now so I want you to get your 4-figure table because we are going to be making use of it now. So evaluating this without using calculator. So the first thing is to construct a table. We have a table of logarithms. So now we are going to evaluate these numbers in the logarithmic side. So now let us write the numerator first. So what we have in the numerator is a cube root of 0.048 times 63.47. All right, so we are changing these numbers to logarithms. All right, so now let's look at this number, 0.047. Now, the first thing is to look for the characteristics of this number. All right, what do you mean by characteristics? Is the number of times you're going to move this point to make it to be in standard form. Right? So now, if I'm to make this number to be in standard form, let's look at it. 0.048. If you have to convert this to standard form, you move this point to the back of the first significant digit, which is 4 here. So you have 4.8 times 10 raised to the power of -2 because you move it to the back. So it's going to be times -2. Okay? So that means the characteristics of this number is -2. So don't forget, in logarithms, now we have two parts in logarithms. We have the integer and the mantissa, right? So whenever you are writing integer that have a negative, so you don't put the negative at the front here, so you put it at the head of the number. So in this case now, the characteristic of this number is going to be bar 2. So the negative is written at the top, bar 2. Okay, so that's the first thing. Now the next thing is to find the logarithms. You go to your logarithms of number. Okay, logarithms of number, check 48 under 0. Now let's do that together. All right, check 48 under 0. Now let us check. Now let everybody check. Okay, so if we check correctly, we are supposed to have 6812. So this is what you're supposed to have. Okay, now look at what we have here. We have multiplication here. All right, so we are changing multiplication to logarithms. Don't forget, when we define logarithm, we say logarithm of a number to a given base is the power to which the base must raise to give that number. So in other words, logarithms is also the same thing as indices. And don't forget, in your law of indices, when you are multiplying, what do you do to the powers? The powers, you add the powers together. So in this case now, so when multiplication comes here, it becomes addition. All right, so you have addition. Now the next thing is to find the characteristics of this number. Okay, so don't forget what I call characteristics is the number of times you're going to move the point to make that number to be in standard form. All right, now look at this, 68.47. So if I'm to convert this to standard form, I'm going to move the point to the back of the first significant digit, which is what? 6. Good. So now move it how many times to the front? 1. So that means the characteristics is 1. Okay, so now you now go ahead and check this in your logarithms of numbers. So now you check 63 under 4. 63 under 4. Make sure you are doing it. 63 under 4. 63 under 4. Okay, and you had difference 7. 63 under 4, add difference 7. Okay, I'm waiting for you to get your answer before I produce my Okay, so now what do you have? Okay, with what I have here, I have 8026. 8026. 8026. Okay, so confirm there, you should have the same thing. All right. Now, before we add these two numbers together, you can see we have cube root here. So now once we have cube root, that means we are dividing this number by 3. Okay, so we are going to divide this by 3. So let's divide it by 3. So what's going to be the results for that? So I'm going to show us how we're going to do that. By 2.6812 divided by 3. So how do you divide this? Many students do not know how to divide numbers of this form. Now, the first thing you look at now is that your denominator must go completely in the integer we have here. The integer we have here, okay? So the integer we have here is minus 2, sorry. So now, what you are going to do now is that since 3 cannot go in bar 2, you look for the next bar that 3 can go completely in it. And that is going to be bar 3, all right? So you must have increased this by a negative 1. So that means this expression turns to bar 3 plus 1.6812 over 3. Can you see that? Now you will see this is 1. This is bar 3. Don't forget bar 3 is the same thing as minus 3. So if you add minus 3 to you add it together with 1, what do you have? You have minus 2, which is the same thing as what we have here. So I'm just trying to express this in another form so that I will find it very easy to divide. Okay, hope you get that. Right now, so now let us divide now. So now when you divide, 3 goes in bar 3. That's going to give you bar 1. Now 3 goes in 16. That is going to be 5. If you remain 1, you put down 1 in front of the next digit, that gives you 18. 3 goes in 18, that is 6. Now the next digit is 1. 3 goes in 1, that is 0. Okay, so now you pick 1 and 2, that's 12. 3 goes in 12, that gives you 4. All right, so that means the division of this is the result of the division of this. So now this gives us about 1.5604. Hope you get that. So now I'm adding this and this together now. Okay, now let me move this one to this side. So which is the same thing as plus 1.8026. So I'm adding the 2 together now. We add the 2 together. Now this plus this, 6 plus 4. 4 plus 6, that gives you 10. You write 0, we have 1. 0 plus 2 plus 1, that is 3. 6 plus 0 plus, that is, okay, 6 plus 0, that's 6. Okay, now 5 plus 8, that gives you 13. All right, so we have 1, that 1 plus minus 1, that gives you 0. So we have 1 here left, so we have 1. So that means the addition of this is going to give us 1.3630. Okay, so now let us now move down to the denominator. So the denominator we have 13.2 raised to the power of 2. All right, don't forget the first thing. If you want to convert this to logarithm, you find the characteristics. So what's going to be the characteristic? That's 1, because you are going to move this point once to the back of 1. So the characteristics is what? 1. And you can see this sign. This sign is division. So once division comes to this side, it becomes what? Minus. You remember your law of logarithms. When dividing, what do you do to the power? you subtract. So that means this is going to be minus, all right? Okay, so now I'm writing minus 1 point. This is the characteristics. So you check 13 under 2. 13 under 2. Before I give you the answer, I want you to tell me what will that be. Let me check that in the comment section. What is 13 under 2? What is 13 under 2? 13 under 2. What do you have? So I'm checking my own too. 13 under 2. Okay, 13 under 2, if you check correctly, we are supposed to have 1206. 1206. So that is 13 under 2. Okay? So now you can see this is raised to power of what? Of 2. So we are multiplying it by 2. So I will multiply this by 2. Okay? Since we have raised to power of 2. So what will be the result? Don't forget we have a minus here, so we'll write the minus first. So minus. Okay, so now let's multiply this by 2. We have 1.1206 times 2. Now let's do the multiplication together. 2 times 6, that is 12. 2 times 6, 12. We have 1. 2 times 0 plus 1, that is 1. 2 times 2 is 4. 2 times 1, 2. 2 times 1, 2. So what we have is minus 2.2412. Okay, so this is the denominator and this is numerator. So we are going to subtract this from this. Okay, now let's do the subtraction. Let's do the subtraction here. Okay, so now 0 minus 2, so we have to borrow 1. That's 10 minus 2. That gives you 8. Okay, so we are left with 2 here. 2 minus 1, that is 1. And here, 6 minus 4, that is 2. Here, 3 minus 2, that is 1. And 1 minus 2, that will give you what? 1 minus 2. It will give you what? That's minus 1. And minus 1 is the same thing as what? Bar 1. Okay? So you cannot write negative at the front. Alright? So you have bar 1, which is the same thing as minus 1. So now we have done the evaluation in the logarithmic form. So now we change this logarithmic value to number. Alright? So we change it back to number. So we are going to be making use of our anti-logarithms table. Okay, so now let's look at it. So we change it back to number. So let's see, what do we have? So how do we check that on our anti-log table? So we check 0.12 under 1 add difference 8. 0.12 under 1 add difference 8. Now can you do that and let me have your answer? Do that very fast. Check 0.12 under 1 difference 8. Make sure you are not checking the logarithm table. You must check the anti-logarithm table. We are changing this value back to number. So check 0.12 under 1 difference 8. Now can you drop your answer? Let me see what we have. Yes. Is anybody dropping anything? Okay. Okay, I can see some answer. Good. Good. All right. Now somebody have gotten the answer. I think I saw someone doing that. So we have 1 3 1 3 2 3. 1 3 2 3. Now let's write the answer here. Now the antilog of this number is 1323. Okay, now we are not done yet. Now, if you look at this integer, you discover that we didn't touch this at all. All right, this is bar 1. So the number of the bars you have here, you put, that's going to determine the number of 0 you are going to put in front of what you just checked. Now I have bar 1 here. Just put 0 and put point at the back of the first 0. So if this is bar 2, I'm going to write 2 zeros there, and I'll put point at the back of the first 0. Hope you get that. If it is bar 3, I will have 3 zeros at the front of this and put point at the back of the first 0. Okay, so now this is the answer to this problem. All right, so I want to believe you've learned one or two things. Now let us see if this is to be marked, what and what will be marked. Now, for finding the logarithms of this correctly, there will be a block mark for that. 1. Now, for dividing by 3, there will be another method mark, 1 for that. Okay, so look at this. For checking this and having 1.8026, there will be a block mark, 1 for that. Okay, now for evaluating and getting this answer, there will be an accuracy mark, A1 for that. Now let's look at this now. For checking 13.2 to be this, we have another block mark. Now for multiplying by 2, you have M1. And then for getting the answer to be this, you have A1. Now let's count. How many marks altogether? 1, 2, 3, 4, 5, 6, 7. 7 marks. You see, you need to know one important thing about this. Even if I check wrongly, but I know that I have to divide by 3, I will still get this method mark. Now what happened is that I will not get this, and definitely there's no I'm going to get the accuracy mark. All right? So the same thing also applies to this. Even if this result is wrong, but I've multiplied by 2, you'll be given this method mark. All right? So now, if you have checked well, there will be a block mark, even if you do not divide by 3. So there will be a block mark. You can see now that your method is much more important than your answer. If you don't get all these ones, even if you end up getting the answer, you will not be given the mark. So that is the more reason why the method is very, very important. So I want to believe you've learned one or two things in this question. Now we are moving to another question. Now let's move to something else. Evaluate is 0.04 raised to the power of -2/3. Okay, now let's look at this question. You have to evaluate is 0.04 raised to the power of -2/3. Now, whenever I have this type of question, the first thing that comes to mind is I should change this decimal number to fraction. All right? So now, what will this give me? What is it going to give me? So I will move the point to the back of the last digit. So I'm moving it 2 times, 1, 2. Okay, so that means 0.04 raised to the power of -2/3 is the same thing as 4/100. Okay, because I've moved the point 2 times. Okay, so raised to power, this power, you put it here, -2/3. Now you have to be careful the way you place your power, because I've seen students doing it in this way, 2/3. If you write it this way, it means something else. All right, you should be at the top. Now -2/3. Hope you can see that. All right, now the next thing now is to remove this negative. Now when you remove this negative, now the denominator moves up while the numerator comes down. So now this turns to 100 over 4 raised to power of 2 over 3. Okay? Okay, I think this is supposed to be 3 over 2. Now let's check this. This is 3 over 2, not 2 over 3. So 3 over 2. Okay? Alright. So 3 over 2. Now, the next thing is look at this denominator. This denominator is going to be the root of the base here. Okay? It's going to be the root. Whatever you have here will be the root. So this turns to the square root of 100 over 4 raised to power of 3. Hope you get that. So now the next thing is to find the square root of 100 and square root of 4. Or better still, you just divide straight away. Now when you say 100 divided by 4, that gives you what? That's 25. Okay. So now, so this turns to 25 raised to power of 3. Oh, sorry. That is, yes, 25 square roots raised to power of what? 3. You get that? We still have the square root there. So square root of this 25, square root of 25 raised to power of 3. So now, you find the square root of 25. What's the square root of 25? That's 5. So that would be 5 raised to power of 3. Yes, so now here you multiply 5 times 5 times 5. That gives you what? 125. So this is going to be the answer to this question. Alright? So how do we award marks? So now, for expressing this in fraction, there will be a method mark, okay, for that. Now, for making this to be the root of the expression we have here, so there will be another method mark for that. And for getting this answer to be 125, there will be another mark. So the total mark for this question is what? 3. Okay. Now let's move down to another question. I'm moving down to another question. Okay, now the next question I have here is under logarithms. So express 45 over 2 as power of 10. Okay, so here's the question. Express 45 over 2 as power of 10. Now, how do we solve this problem? Now, the first thing to do is to express this in decimal form. So, 45 over 2 is the same thing as 2 goes in 4, 2. 2 goes in 5, that is 2 remainder 1. That is 1. So, you put 0 at the back. So, 2 goes in 10, that is 5. So that means the division of this is 22.5. So then you change this number to standard form. So you move the point here to the back of the first significant digit, which is 2 here. So you have 2.25 times 10 raised to the power of 1, because you move the point to the front once. Okay, good. So now the next thing is to write 10 raised to the power of 0. So you check 22 under 5 in your logarithms of number. So I want you to do that and tell me, drop your answer, 22 under 5. So you check the logarithms of this, 22 under 5. What do you have? So I'm expecting more answer now. So 22 under 5. Let's see. Who is dropping the answer? 22 under 5. Okay, I've not seen anybody dropping anything. 22 under 5. Is anyone checking? 22 under 5. Okay, seems okay, so if you check correctly, now you will have 3, 5, 2, 2. So that is what you have. 3, 5, 2, 2 times 10 raised to the power of 1. Okay? So now the next thing now is to join these together. You join them together. Now they have the same base, so you add the powers together. So this is going to give you 10 raised to the power of 0.3522 plus 1. Okay? So now you have 10 raised to the power of, you add this 1 to this integer here, so you have 1.3522. So this is the answer. So you have expressed this number as power of 10. So that means 10 raised to the power of 1.3522 is equivalent to 45 over 2. Alright, so how do we award marks to this? Now for expressing this number in standard form, you have M1 for that. Okay? So, and for getting your answer, you have A1. Alright, so 2 marks for that question. Okay, that's very simple and straightforward. Okay, so now let me do one more before we move down to the very last one. Okay, let's look at this. Solve x raised to the power of 1 over 2 plus x raised to the power of 1 over 4 equals to 12. Okay, you have to solve what we have here. All right, I've done something similar to this before, but I observed that many people are still asking questions about the solution. So now let's go through the solution of this problem together. Okay, so now let's look at it. We have x raised to the power of 1 over 2 plus x raised to the power of 1 over 4 equals to 12. Now, the first thing that comes to mind when I see this type of question is I will find a way to express x such that it's going to have a power of 1 over 4, because I'm seeing 1 over 4 here. That will help me now to be able to join the two together. Otherwise, it may be very difficult. So I will find a way to bring out 1 over 4 here. So what can I do? Now, I know that 1 over 4 times 2 is going to give me 1 over 2. I know that because 2 will cancel 4 here. So I will have this. So let me express this as x raised to the power of 1 over 4 raised to the power of 2. Since I know this is multiplying this, so I can write this plus x raised to the power of 1 over 4 equals to 12. So this is my objective. Now I can now see that I have an expression x raised to the power of 1 over 4 here, and I also have here. So I will say let m be equals to x raised to the power of 1 over 4. So that this equation now turns to m squared plus, now this is m, okay, plus m equals to 12. But can you see that now? So now what we have here now is a quadratic equation. So I just need to solve this. So I have m squared plus m minus 12 equals to 0. So you transpose this. So once it comes here, the sign changes. All right, so how do we solve this? Now, you must have been solving a quadratic equation before now, but I'm going to explain how we are going to solve this. Now, the first thing is to locate your sum and product. Now, what is sum? Sum is the coefficient of m, while the product is the multiplication of the coefficient of m squared and minus 12. Okay, so now sum is plus 1. That is the coefficient of m. Now product is 1 times minus 12. So product will now be what? Minus 12. Why are we writing this? Now the objective is I want to divide this m into 2 parts. There are several ways I can divide m into 2 parts. This m is still the same thing as 2m minus m. If I say 2m minus m, we have what? Plus m. If I say 10m minus 9m, it's still going to give me 1m. 100m minus 99m is still going to give me 1. So we have several ways of expressing it, but there is one that is going to suit what we need it for here. So now how do we do that now? So now look at the sum and product. You look for two numbers such that when you multiply the two numbers together, you are going to have minus 12. That is the product. And at the same time, when you add the numbers together, you have what? Plus 1. Okay, so now you begin to think of the numbers. All those, you see, the numbers you are going to list must be factor of the product. So I begin to think of 1 is a factor of 12. I think of 2. I think of 4. Have I said 3 as well? I think of 6 and 12 itself. Okay, so now the two numbers will be minus 3 and plus 4. Look at these two numbers. If you multiply minus 3 by 4, you are going to have minus 12. And at the same time, if you add these two numbers together, plus 4 minus 3, you have what? Plus 1. So that means this will be minus 3m plus 4m. That is the same thing as your m here. So I'm going to replace m with minus 3m plus 4m. All right? So that is what we are going to do now. So this equation turns to m squared minus 3m plus 4m minus 12 equals to 0. Can you see that now? So we just splitted this into 2. All right, now so look at these two terms. What is the common factor? That is what can go completely in these two terms. So that is m. So we have m. When you divide this by m, you will be left with what? M. Divide this by m, you have minus 3. Okay, the same thing here. Divide this by 4, because 4 can go here, 4 can also go here. We have plus 4 being the common factor. So we divide this by 4, you have m. Divide this by 4, you have minus 3 equals to 0. Okay, so the next thing is to factorize. We now have two terms, the first term and the second term. So the common factor, what can go completely in this and can also go here, is m minus 3. So when you divide this, you are left with what? M plus 4. So you just bring this and this out. So you are left with m and 4, okay, equals to 0. Now when you look at what we have here, the left hand side, you see that we have these two numbers multiplying each other. So this and this is multiplying one another to have 0. So if you have two numbers multiplying each other and the result is 0, you know one of them must be 0, or the two are 0. Okay, so now it's either this is 0 or this is 0. So we have m minus 3 is 0, or m plus 4 is 0. That's the implication of this statement. So we now have m equals to 3 or m equals to minus 4. All right, so the next thing now, don't forget, we said that m is the same thing as what? X raised to the power of 1 over 4. So here now we have x raised to the power of 1 over 4 equals to 3. All right, so now here you can take you can multiply the power of this by 4 and multiply the power of this one by 4, so that we're able to cancel this 4. So you have x raised to the power of 1 over 4 raised to the power of 4 equals to 3 raised to the power of 4. So now this 4 will cancel this 4. So you have x raised to the power of 3 raised to the power of 4. And the result, therefore, x equals to what? 3 times 3 times 3 times 3. That gives you what? 81. All right. So this is the value of x. Now, when you look at the other one, by the time you solve it, your result will not satisfy this equation, because you can always check back. If you check back with this, you can try that. If you check back with this, you insert it here, you will see that you are going to have 12. But when you find this, you solve this, you substitute here, you will not get the result. So that is a strenuous solution. So you can try that. Just follow what I just did now and substitute inside this equation. You will see that you will not have the result. The reason being that you cannot get the even root of a negative number, right? So that is that. So that is the solution to that problem. So how do we award mark to this? So now the first thing is, for doing this manipulation here, so we award a method mark for that. Okay, and for getting this quadratic equation, we award B1. Now for solving, having m squared minus 3m plus 4m minus, so we have m1 for that. Okay, and for getting these two answers, we have a1, a1. All right, now for solving, now you must have solved here, you create this, so you have m1, and for getting your answer to be this, you have a1. So the total marks altogether will be 1, 2, 3, 4, 5, 6, 7. 7 marks. 7 marks altogether. Okay, so that is the solution to that problem. All right. The last thing I'm going to be doing for today is under set theory. Set theory. Set theory. All right, now what I'm going to be doing today, I will just introduce you to set theory, what you need to know, and in the next class, we are going to go into set theory properly. Now, let me start by telling you what set is all about. Now, a set is the collection of well-defined items. Collection of well-defined items. So when we are talking about set, we are talking about a set of items that are well-defined. Now, let me give you an instance. If I say a mathematical set, everybody knows what's supposed to be there. Now, you know you need to see a ruler, divider, compass, and so on. Now, nobody will think of a car. Nobody will think of rice because it does not belong to that set. That set is well defined. But look at an example. If I say set of young people in Nigeria, set of young people in Nigeria, you will see the word young in this case is ambiguous. It's ambiguous because you will see a man of 60 saying he's still young. You understand? While you will see a man of 35 or 36 telling you that I'm very old, I'm a old man. Do you understand now? So now it's a relative statement. You can see that statement, that set, it is not well defined. So when we are talking about sets in mathematics, they are sets of items that are well defined. And now that takes us now to different types of set of numbers, because we are going to be dealing with numbers and other items. So now let me quickly introduce you to the set of common numbers that you are familiar with. Now the first one is natural number. Natural number. So how do we define natural number? Natural numbers are just the set of counting numbers. Set of counting numbers. So we have 1, 2, 3, 4, and so on. These are sets of counting numbers. Set of counting number. You count 1, 2, 3, and so on. So this is what we call natural number. So now we move down to another type of set of numbers, which we call integers. Integers are whole number. So when we say an integer, we are referring to whole numbers. So now you have -3, -2, -1 is 0, 1, 2, 3, and so on, million, trillion. They are all whole numbers. You can see they are all standing alone. So they are whole numbers. So we can have a negative whole number and also positive, right, as you can see now. So another set of number we call even numbers. So now I want you to get the definition of even number rightly. Even numbers are natural numbers. They are natural numbers, or you say they are counting numbers. So they are set of counting numbers that are divisible by 2. Set of counting numbers. That is set of these numbers. Not all the natural numbers, but the natural numbers that are divisible by 2. So we can select them. This is an even number based on the definition. This is also an even number. All right. So now we have 5, we have 6. 6 is also an even number because these numbers are divisible by what? By 2. So that makes them to be an even number. So it will be wrong for me to just say they are just numbers that are divisible by 2. So we have to be particular about the natural form of the number. So they are natural numbers that are divisible by what? By 2. So that takes us to another set of numbers we call odd numbers. Odd numbers are also natural numbers. They are natural numbers that are what? Not divisible. That are not divisible by 2. Just opposite of your even numbers. They are not divisible by 2. Example, we have your 1, you have your 3, you have your 5, you have 7, and so on. Alright? Okay, so now let us look at another type of number which we call prime number. Prime numbers. Prime numbers are also natural numbers. Okay, you will see that I'm defining natural numbers. They are natural numbers that have only 2 distinct divisors. They have only 2 distinct divisors. So prime numbers are natural numbers that have only on the line, only 2 distinct divisors. That is, it's only 2 numbers that can go in there. Now the list of them, we have 2, okay, followed by 3, followed by 5, followed by 7, and so on. All of these numbers that I'm listing now, they have only 2 divisors. Now look at these 2 for instance now. The 2 numbers that can go in this are 2 and 1. 2 and 1. No other number will go without a remainder. Now look at these two. 3 has only 2 distinct divisors. That is, they are not the same thing. So this 5 has only 2 distinct divisors, and so on. Alright, now that now takes us to another set of numbers, which we call composite number. So what do we call composite number? Composite numbers are also natural numbers. They are natural numbers that have more than 2 divisors. They have more than what? 2 divisors. I say they have more than 2 factors. Alright? Unlike prime numbers that have only 2 distinct divisors. Composite numbers, they are natural numbers. They are natural numbers that have more than 2 distinct divisors. So now the list of them is 4, followed by 6, followed by 8, 9, 10, and so on. When you look at these numbers now, they have more than 2 divisors. They have more than 2 divisors. Now let's take, for instance, now look at 4. 2 can go here. 1 can also go. 4 can go. So this one has 3 divisors. So it's more than 2. That makes it to be what? A composite number. So the last set of numbers I'm going to define here now is a perfect square. Now perfect square are natural numbers whose square roots are integers. They are natural numbers whose square roots are what? Are integers. So example, we have 1, we have 4, we have 9, we have 16, we have 25. All of these numbers, if you find their square root, you will have integer. Alright, all of these. When you find their square root, you have integer. Square root of 1 is plus or minus 1. Square root of 4 plus or minus 2. Square root of 3 plus or minus 3, and so on. Square root of 16 plus or minus 4, and so on. Alright, so these are the sets of numbers. So you can see now that when we talk about sets, they are well defined. If I say, give me 2 examples of composite number, you know the number I'm talking about. You cannot mistake it for another number. Okay? So now, in set theory, we enclose the elements of set in a curly bracket. Take for instance, if I have set of numbers like 2, 3, 4. Now, if this must be a set, it must be enclosed in a curly bracket. Now, this is a set. So if you have it this way, 2, 3, 4, this is not a set. So it is enclosed in a curly bracket. And sets are represented with capital letter. So now I can represent this set of number as set of A. Set of A is the set of 2, 3, 4. You understand now? Okay? So it can be written in this form. And also, sets are also represented on Venn diagram. So it's just a circular form of this form. So like what we have here, 2, 3, 4, you can have it here, 2, 3, and 4. All right? So you can see, so this is a Venn diagram. So I can target A. So this is set of A. All right, so I'm going to be stopping here. This is just an introduction. So in the next class, we are going to start from where we stopped today. I want to believe you've learned 1 or 2 things. Now, please don't forget to subscribe to this channel if you have not done that, and tap the like button. And always remember to drop your comments about the class. I want to know where you are all watching from. So please, before you leave today, make sure you drop where you are watching from. Thanks so much. Bye-bye.